This video is on finding the area of a regular hexagon. So one more time, we're going to remind ourselves about 30, 60, 90 triangles. The side that's across from the 30-degree angle is half as big as the hypotenuse, and the side across from the 60-degree angle is root 3 times the length of the small side. Finding the area of a regular hexagon with side length 8. So if each of the side lengths is 8, then what I'm going to do is I'm going to just kind of figure out that they're all 8. Then I will use the process for finding the area of a regular polygon. So I will draw this triangle and find the central angle. Now in a regular polygon, we can always take 360 and divide it by the number of sides to get the number of degrees. So this is a 60-degree angle. Then I can do the apothem split. And so that's a 30. And this is a 60, because if this 60 gets split in half and that's a 30-degree angle, this is a 90-degree angle, that has to be 60. So I have 30, 60, 90 triangle here. So if this side is 8, that means this gets cut in half, and that's a 4. So I'm going to copy this. That's an 8. Oh, no, that's not an 8. That's a 4. So this is 4 over 1. Using ratios, 4 over 1 equals the apothem over the square root of 3. I multiply the square root of 3 over, I get a equals 4 times the square root of 3. So I don't even need the radius. I can figure it out pretty quick because each of these triangles is an equilateral triangle, because that's a 60, that's a 60, and that's a 60. So if this side is 8, the radius is also 8, and I can also use the 30, 60, 90 here. But I don't have to do that, because in order to find the area of this triangle, I just need to do 1/2 base times height, and that does not include the length of this side. So 1/2 times the base, which is 8, times the height, which in this case is the apothem. So that's 4 root 3. So I get 16 times the square root of 3. That's the area of this green triangle. So we've done the apothem split. We used a 30, 60, 90. We found the area of this triangle. Now our job is to multiply by the number of triangles the shape would have. And if we look at this shape, there are 6 triangles that are exactly the same as this green shaded triangle. So I take this 16 root 3 and I multiply it by 6. So 96 root 3 units squared is the area of this regular hexagon. Find the area of a regular hexagon with apothem 9. So, or apothem. So that's a 9. Let's follow the process. Step 1, central angle, which we already know is 60 because we've already done hexagons for a while. Well, this is problem 2 anyway. Then we do the apothem split, that becomes a 30. So this is now a 30, 60, 90 triangle. I already have the height of the triangle I'm trying to find the area of. All I need to do is find the base, or the side length. Now notice that since this is an equilateral triangle, I could either find this length, or I could find the length of the radius of the hexagon, because since this is an equilateral triangle, the radius is going to be equal to the side length. So that's b, that's x, this is 9. I'll just find b, because that's going to give me the side length anyway. So 9 over root 3 equals b over 2. I cross multiply, I get 18 over root 3 equals b. 18 over root 3, I can simplify to 6 times the square root of 3. We did that on a previous video, so you can kind of see how that works. So this is 6 square root of 3. So now in order to find the area of this triangle, 1/2 times 9, which is the height, times 6 square root of 3 gets me 27 square root of 3. 27 square root of 3 is one triangle. I need 6 of them. So I'm going to multiply 27 root 3 by 6. So the area of this entire shape is 162 times the square root of 3 units squared. Radius 4 in a regular hexagon. So the radius is 4. Find the central angle. Do the apothem split. So 60 divided by 2 gives me 30. If this is 4, this whole length is 4 because remember, this is an equilateral triangle that I'm finding. So I have a 30, 60, 90 triangle. My main objective is to get the apothem or apothem. So this is 4. This is, I'm sorry, that's not 4. This is A. This is 4. And I know this is 2 because this is half the length of this. So if I want to find A, I can do 2 over 1 or 4 over 2, either one, equals A over root 3. So the apothem or apothem is 2 root 3. So the area of this triangle is 1/2 times the base, which is 4, times the height, or the apothem in this case, which is 2 root 3. So the area of one of these triangles is 4 times the square root of 3. There are exactly 6 of those triangles in this diagram. So I have 6 times 4 root 3. So the area of the hexagon, that's a terrible drawing, sorry. Area of the hexagon is 24 square root of 3 units squared.